So my next guest today is Rob Bajewski. He's the president and CEO of a company called DATEST up in the Valley. Nice to see you again, Rob.
Good to see you, Trevor. Thanks for having me.
Yeah, no, it's a pleasure. You do some really interesting and innovative stuff. You really are a very advanced testing lab for companies that are producing product, but also people that are looking to do root cause analysis and that type of thing.
Yes, we've become that by force of circumstance and the demands of our customers, where we're like SMTA. We're a 40-year-old company. We started at about the same time that SMTA did in 1984, and what was then a simple in-circuit testing facility has become a full-service testing laboratory, because as requirements have evolved, specifications have become far more complex, where customers don't want just binary test results, pass, fail. They want to know why.
Right.
And they want to know why to a level of detail and a level of intricacy that was not needed, say, 15, 20 years ago.
Right.
Where now they want to know why it failed to the component level, to the data level, to 3 decimal places with a high level of precision and repeatability.
Right.
So we're called upon to provide that data, and we've had to make the investments to do it.
Right. No, I bet. I mean, so a big part of your business is contract testing. You know, where you've got the suite of inspection tools and capabilities and skills that other companies just don't have in-house.
Correct. We have 2 businesses. DATEST kind of splits down the middle between the classical test engineering business, where we do the traditional methodologies, so in-circuit testing, flying probe, automatic X-ray inspection, JTAG boundary scan, and so forth.
Right.
The other half of the business is non-destructive failure analysis and inspection using imaging technology. So 2D, 3D X-ray, CT scanning to a high level, high resolution level.
Right.
And what has happened in recent years is engineers get wise to the fact that we have high-end capabilities in imaging, and so inevitably they bring us all kinds of other stuff besides just printed circuit boards. I mean, printed circuit boards are our,
bread and butter.
But probably a growing percentage is other things, other materials, other objects for totally different purposes, not necessarily electronic subsystems.
Right. That's incredible. So before we started today, you told me you were becoming an aerospace company.
We are.
Explain yourself.
Well, about 70% of our business currently is aerospace or aerospace related, either from government agencies with acronyms or from prime or subcontractors to those agencies.
Right.
This could be traditional avionics type electronics, modular things, to material science applications, where we're looking at packaging for rockets, packaging for space vehicles, to measure stresses, to get some appreciation or validation of the longevity of those materials, particularly in the reusable spaceflight sector, where engineers are trying to determine this item has made 4 orbital missions, has certain stresses exerted on it. What is the risk in sending it on a 5th or even a 6th mission? And so we provide some of the evaluation data points to enable them to make those determinations.
So you look at the stress that's occurred within these packages, etc., and you measure the strain that's happened across these substrates and materials.
Strain, wear and tear, heat, the effects of heat from thermal cycling, pre-thermal, post-thermal, that sort of thing, to get some sort of approximation or predictive approximation of the life cycle of the material.
Right.
The watchword is reusable. Everything needs to be reusable these days.
Right. It's interesting that, because we had a discussion this morning about heterogeneous materials for advanced packaging, and one of the panelist was saying that one of the truly challenging issues is measuring the strain across the different materials and how they react differently,
right,
and pull differently. So it's really difficult to try and measure that and get a handle on it.
Yes, and so we take images of the physical characteristics of certain materials subjected to certain strains and feed back that data to reliability engineers at many of the name brand aerospace companies and that whole ecosystem of subcontractors throughout the United States that serves them.
Right. How are you finding the materials changing in the industry? Because there's new applications coming in. We're going from silicon to gallium arsenide to glass to all these different substrates that they're talking about.
From our viewpoint, emphasis on ruggedization, emphasis on long-term reliability, emphasis on vibration, ability to withstand prolonged and very heavy vibration, 6, 7, 8, 9G forces,
right,
and still operate reliably.
Yeah. Now it must be a fascinating job because you see so many different things.
I could never have dreamed some of the stuff we see. I'm a lifelong printed circuit board guy, and I'm looking at heat shields now.
Right.
And it's actually fascinating. We learn a lot, and we obviously provide useful data to our clients, and they like what we do because we do it very quickly and with, like I said, a high level of precision, and business is good.
So does business come in fairly instantaneously? I mean, something that needs to be done and turned around very quickly.
Yes.
So you probably don't have a workload that's planned 6 months in advance, but it's more stuff that happens.
I typically don't know what we will be doing 1 month from now.
Right.
Our key client, our stereotypical client, is an engineer with a problem who needs an answer in a hurry. Usually line down situation, or he or she is at an inflection point in a process where an anomaly has to be identified before the process can be turned on again.
Right.
So there's a high degree of pressure. There's an emphasis on very quick turnaround. We're talking days, not weeks.
Yeah.
And often that involves disrupting weekends or working long hours or all night in certain cases. If it's a long CT scan, sometimes you have to set the system up at night and let it run all night to get the requisite scans, and then you come in the morning and you download the data and do all the post-processing and all the manipulation that follows that.
Right.
So yes, we see all kinds of strange applications, but that's the fun of the business.
Yeah.
We're not always sure, depending on the material, whether we can give useful information to the customer or whether we can penetrate. Certain metals come to mind of higher density, but then we're just honest to the customer and we tell them we're willing to try. We don't know what the outcome will be, but we're going to give you some of our time.
Right.
In return. Tell us what matters to you, analyze the images that we give you, and if the data is useful, let's work out a program from there. And that's been a very successful approach for us.
Yeah. It's as I say, a fascinating subject. I wish you all the best, Rob, and I want to thank you for coming in and telling us about it today.
My pleasure. Thank you, Trevor.
Imagine the competitive advantages of producing high mix and high volume PCB assembly on a single SMT line, running non-stop, even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment.